Hello and welcome everyone. Thank you for joining us today for a webinar on AI bias, what every CTO needs to know for successful AI deployment. Good afternoon for those of you in Australia and warm welcome to our viewers tuning in from different time zones. Please make sure to introduce yourselves in the comments and let us know where you're watching us from. Whether you like it or not, AI is becoming a critical part of every organizational strategy. But this adoption comes a crucial question. How can you ensure that your AI initiative aren't compromised by hidden bias? So in this session, Brian will break down the bias in AI, the risk they pose to your organization, and hopefully equip you with the insights to tackle these challenges. Bias in AI isn't just a technical issue, it's a leadership challenge. And today's session will provide practical strategies and tools to help you navigate these complex gray areas. So we encourage you to engage with us by posting your questions in the comments. We'll try to address as many questions as possible during the Q&A at the end of the Brian's presentation. And we'll be sure to follow up afterwards of anything we don't answer live. I'm Jana Martins, talent and community lead From Here On, and I'm excited to introduce our Chief AI Officer, Brian Lowe. Brian brings a wealth of knowledge and practical approach to today's complex topics. So that's enough of me. Now, without any further delays, I'll hand it off to Brian for today's presentation. Brian, please.
Thanks, Jana. Appreciate that. It's great to be here. All right, let's jump in if we can. So I'll just jump to the first slide. Today, obviously, bias in AI is quite a big topic as a subset, let's say, of fairness in AI. There's a lot to it and a lot of research being done, but also a lot of policy being developed and so forth. So we'll cover as much as we can in the time that we've got. We've got about 20 minutes, so it's going to be a fairly whistle-stop tour. But what I'm going to try and do is call out the salient aspects of what you need to know as CTOs and technology decision makers, and where the distractions might be, where it's important to focus. I'm going to talk a little bit about why bias is important. Sometimes there's a tendency, if we're working in purely technology areas, to think those things are really outside what we're looking at. My experience is that this, along with a number of other hygiene issues, let's call them, are things that it's very important to get your arms around. They can be real showstoppers if you're not on top of it. I'm going to talk a little bit about the types of bias with a few examples as well. There are different ways that bias can manifest in the AI context. And then finally, of course, I want to describe a simple approach just to addressing bias without some of the distractions I've talked about that should keep most of your stakeholders happy. It won't cover everything, but I think it's a fairly practical way to address this problem. What I want you guys to take away from this, if all goes well, is the notion that bias really is important. It's something you do need to address. There's a lot of ways of trying to address it that are out there at the moment. I think some of those are probably more academic, and there is a couple of practical things I think you can do to step into it. All right, sorry guys, I'm just going to move into the next slide. So I'm going to give you a little bit of a background about me. I don't want to talk about that too much, but I just want you to understand a little bit about where I'm coming from. I've been in IT for over 25 years, working in this trade. I actually started off working in AI in the 90s, before the infamous AI winter, or winters, let's say, that descended upon us. I've been working in AI and data for most of my career. In the initial stages, as I indicated, it might mean something to some of you. I worked in areas like case-based reasoning, deductive database systems, predicate logic, those sorts of areas, back when we thought it was going to be easy, or at least easier than it's turned out to be. So it's been quite tumultuous. I did my PhD in information systems, specializing in the early stages of database systems in this area. One call out that I'd like to make while I remember, there are some idiosyncrasies to do with the formatting that you'll see in the slide pack, that's to do with some kind of upload problem with the system, the platform that we're using. So please forgive us for some of the rougher formatting there. I noticed Swinburne University here is not in the consistent style with the other titles. That's an artifact. In terms of my experience, I was at National Australia Bank for a while doing data AI stuff there. I was assistant director for the Bureau of Meteorology way back when, looking at some of their large-scale implementations and obviously the massive amount of data that we had to take care of there and the models therein. Swinburne University, I was there for a while as Director of Enterprise Architecture and Information, again looking at data and AI. And then a few years ago, I was the CTO at Movis, which was a scale-up AI-based company that addressed condition monitoring and other sorts of AI models. So that's a whistle-stop tour of my background. I'll get into something a little bit more interesting. All right, I'm going to start with a few cautionary tales here. And as I said at the beginning, it might be tempting to think that bias in AI is probably not going to be central, or at least not something that you need to put a lot of energy into. Again, the formatting here, sorry about that. The first one that jumps out very recently, I think from memory 2023, there was a university in Holland, Vanderbilt University, that implemented an AI detection tool for plagiarism. And it started falsely accusing students of plagiarism. It was quite a big scandal in the world of tertiary education, and eventually Vanderbilt University and a number of other universities turned off their AI detection system, which was Turnitin. It's a very popular solution in that space, because they had lost confidence, and of course because the outcry, I think, from some of the students and even the staff as well was more than they could handle. It's a good example of how algorithmic bias can manifest. And to be clear, this problem started with data bias, and then it sort of became what we call algorithmic bias. This is when it gets baked into the way in which the algorithms within the models work. What it turned out to be was a bias against non-native English speakers. And of course, Vanderbilt University has many non-native English speakers, so it became quite a problem. And that non-native aspect triggered something algorithmically that the detector decided was plagiarism. So it's an interesting case. The next one is, I think, something that you probably all remember. It made the headlines many years ago. I think probably 2017 was when most of the fallout happened. This is Microsoft's Tay, which was an AI chatbot. It used models that we don't use anymore, but it's a really good illustrative example of what we call interaction bias. And that's the bias whereby you interact, or your user body interacts with the system, and gradually it changes, the model changes over time and becomes biased. In this case, I think this example, I find it both terrifying and hilarious at the same time. Microsoft Tay was modeled on the avatar of a 19-year-old girl full of energy, etc., enthusiasm. And after, I think, about 2 weeks of schooling from the user community, who were trying to challenge it, to be fair, it became a racist neo-Nazi with a potty mouth. As I said, hilarious, but also quite troubling. And you can imagine how that kind of drift would affect internal systems, for example, were it to be implemented. The last one here is an example of bias against Indigenous Australians applying to a financial institution for credit applications. And this has to do with latent space bias and some correlations with underlying factors that didn't have to do with the fact that these applicants were Indigenous Australians, but it manifests in that way. And it's quite a salient example of how things can manifest in an unexpected way, even when you've done your due diligence with the data and algorithms, theoretically. All right, so that's a little flavor of the different kinds of bias that we can look at. Just to nail this aspect here, I'm going to run through a few headlines of why bias has to be a factor that you consider before you can do any kind of successful implementation, particularly when it's client-facing. of course. The first thing is the reputational damage. If it gets out that your system has bias or is perceived to have bias, that's going to be a huge thing to try and climb down from. I've got a little case study up here in the top right corner. Air Canada had a chatbot that it had available that gave mistaken information to one of the customers. The customer then acted on that information. There were financial consequences, and that customer was quite rightly pretty upset and tried to recover money from Air Canada. And Air Canada, I think, in a spectacular display of bad judgment, in my view, decided to go to court. And their argument there was that they're not responsible for the output of their chatbot. And of course, that was considered an absurd argument. They are indeed responsible for the dissemination of information from any of their sites, whether via chatbot or any other means. And there were severe financial penalties in addition to, of course, severe reputational damage. Now, in that case, the chatbot didn't misinform because of bias, but I think it's a really illustrative example of the way in which all organizations need to be responsible for what they're putting out there, whether that comes from a model or otherwise. Obviously, legal landmines, the discrimination lawsuits going on at the moment in the US over selection bias around recruitment. There are compliance obligations. I know from my own time at National Australia Bank, working with APRA, our prudential body, they were very interested in making sure that any bias in our systems, AI or not, was uncovered and addressed. So these are the kinds of things you need to look at. Obviously, if it does get out that there's bias, then that erodes the internal trust within your organization. Your own team then have no faith in what they're using, that it will be unbiased, and that can have knock-on effects for things like your ability to recruit. I know that when I joined National Australia Bank, this was on the tail of the inquiries that had happened across all banks in Australia after some fairly bad behaviour. And one of the questions that I was asked when I came on board was, why would you want to join this organisation, given the reputational damage that's been done? So they're the sorts of things that can happen. And of course, customers can face a crisis of confidence as well. If there is perception of bias, they are much less likely, in my view, to engage with your systems and to trust what those things tell them. All right, so this is all fairly obvious stuff, just to nail completely the notion that you do need to understand bias and to make sure that you have a good approach to mitigating it. There are a few techniques out there that you'll read, and some of these I've tried myself with my teams to mitigate bias. I thought I'd start with a bit of debunking. These are some of the things that, in my view, don't really work. The first one is what I'll call data shaping. And what I mean by that is slicing and dicing your data, or correcting your data, or in some way sampling your data to compensate for bias. And the classic example that's always used is facial recognition systems that perform better on white faces than they do on black faces. And that can be to an extent because if you sample the data in a place like Australia, or a place like the United States, you're likely to get much more data for white faces. Now, the problem with this approach is you end up constantly profiling data, renormalizing to chase the drift in the data. More alarmingly, if the representation of data is not the core problem, you can make things worse. And so in the case, the reason the black faces example is a very good one is because there are physical aspects to why those models don't perform as well as data bias. The physical aspects have to do with contrast in the images themselves. So my view, that doesn't really work. It can take a lot of money, a lot of time and focus, and ultimately doesn't give you what you think is going to give you. Similarly, for algorithmic strategies, they normally rely on heuristics. You end up with a whole bank of heuristic rules that contradict each other. You can't tell whether or not they're actually working, and very quickly it grows over time into something that's creating more of a problem than it's solving. In addition to that, synthetic data, it's become quite popular in the past, I don't know, year or two, let's say, where you are using algorithms to generate synthetic data to go into your data corpus to compensate for underrepresentation in some areas. It's a very circular approach to the problem, but again, you end up chasing your tail for similar reasons to the data shaping. The final one, I think, is probably the most alarming, and that's the removing attributes from the data that are sensitive. So, for example, if you think that ethnic background or gender or other factors are sensitive, the temptation is to remove that data. So this is the sort of, in your approach of sticking your head in the sand. The problem with this approach is that often the problem doesn't come from that data, from the measured sensitive data. It comes from some underlying data in the latent space. So an example of that, I talked before about discrimination against Indigenous credit applications. The problem turns out to be the correlation between that information and socioeconomic factors such as income, type of employment, and other things. That latent space data still exists in the corpus. And that makes the problem worse because then you lose any visibility over what's happening by removing perceived sensitive data. So all of these things, you'll see a lot of information around. I think that they are not the areas that you should put your focus. The next one I want to talk about, or the next set of approaches I want to talk about are things that are necessary, things you actually have to do, but don't solve the problem. They're just things that you need to do. They will certainly help, but they won't solve the problem. The first one is, of course, auditing the training sets. That is important, but I'll give an example of why that doesn't work in a little while. But essentially, you only find what you're looking for, and even then, it's the old analogy of searching for your car keys under the lamppost because that's where the light is. You end up missing some things because you just don't know that they're there. The second one is explainability. This has been a hot topic for a number of years now. It has struggled to get anywhere that people are satisfied with. What I mean by explainability is getting models to explain why they've reached a certain conclusion. So, for example, credit card application, why is a particular applicant rejected? It can be quite a challenge depending on the kind of model that you're using. Those techniques, explainability is not really there to the level that you need in order to address something like bias, in my view. And then the final one, of course, is organizational practices. So you do need to make sure that you've got a diverse, inclusive AI development team. I don't mean the population of the team. I mean they understand those concepts. They understand how important they are in the data and in the models, but it doesn't address the problem. It's just something you need to do. All right, moving to the next one. What is the magic bullet? This is the $64,000 question. The magic bullet's fairly straightforward in my view. It's model testing. So rather than testing and profiling and shaping the data itself, test the output of the models themselves. And then whatever the underlying cause of bias, should it be there, it's going to manifest in the outputs of the models themselves. So decide what to your organization you're interested in mitigating. So, socioeconomic group, for example, race, gender, etc. These are policy decisions at the stakeholder level, the executive level. Decide what's important to you, and then from there, test for it in the model outputs themselves. All roads lead to Rome, or in this case, all roads lead to an outcome from testing. In addition to that, of course, make sure your stakeholders are committed to those areas so that you don't have shifting goalposts. Make sure they're on board for those things, and then test the results of the model against those. Once you've got those, if you detect bias, then you can feed that back into the models and even the data itself. It's worth noting here as well that each test outcome, each identification of bias, should that happen, will require different techniques in order to address them. That's a whole can of worms, and I may get into that in subsequent webinars if there's enough interest, but you'll need various different techniques once you detect it. But detecting is the key. That's the main thing if you can do it. All right, so practical approach. This is very high level. It just gives you a bit of a cookie cutter step by step on what you'll need to do. The first one is, of course, developing organizational policy. And I know that's not part of the technology stuff, and it might not be as much fun, but it is absolutely key to what you need to do. Make sure your areas of bias are represented in your policy, ratified at the right level, and represent what the organization is interested in. Embed that into the way in which you conduct the teams themselves. There's an interesting call out in the top right corner there. An amusing anecdote, a review of Fortune 500 executives shows that there's an underrepresentation of people with red hair in the executive. So does that mean there's a systemic bias in the hiring practices, discriminating against people with red hair? Yes, no, maybe. Nobody cares, right? I mean, that's the thing. Nobody cares. So you'll find what you're looking for is the point that I'm trying to make here. So whatever you decide, that's what you're going to be slicing and dicing by. You will get bias all across your data corpuses in all kinds of dimensions. So decide what's important. The next step, of course, testing. Test the absolute crap out of your models. What kind of output are you getting? Do those outputs skew in any way? So those tests are fairly straightforward to do, standard distribution tests or profile tests from the outputs, but make sure that you address those. And then finally, the organizational practices, which I talked about a little bit earlier. Make sure everyone's educated on this topic, they understand key elements of it, etc. Make sure you're recruiting with that in mind. It's not a central factor, but it is an important factor. Make sure that you're training staff, users, and practitioners as well to understand these issues, and make sure you've got clear guidelines in place as well. All right, how are we doing for time? I think we're doing okay. All right, good.
Minutes, yeah.
Say again?
Few more minutes, yes. We can go through tools, yes.
So no discussion to a technical audience would be complete without some kind of tools. And in this case, I'm afraid to say there are no magic bullets in the tools space. Methodology, yes, but the tools themselves, we're still at a fairly early stage in my view. There are a number of tools out there that will help address AI bias. The two that stand out to me, more I think because of the backing that they've got than anything else, are the ones from IBM and Microsoft. Now, having said that, this is in constant flux. If I were to give this presentation 2 months from now, I may have a bigger list or even a different list. But the two that stand out are IBM's AI Fairness 360, which is really a toolkit. It's a community developed set of libraries and other things. It provides algorithms to mitigate the bias through the development lifecycle itself. So I talked about incorporating output testing into your lifecycle. This steps into that breach quite nicely, and it becomes part of your AI ops or ML ops development and deployment pipeline. I think it's a bit limited in my view. I've not actually used it in anger, so that's an uninformed opinion, but I've certainly read a lot of reviews and dug into the way in which it works. I think it's still early days for this product. Microsoft's, I have used FairLearn, although not to any degree of expertise at all. That's, again, an open source toolkit for assessing it. It is also early days. It allows you to put in metrics and other things. You can use an algorithmic approach if you want corrections as part of your mitigation. So, for example, I talked before about bias in credit card applications. You may choose, and certainly the institute that I was talking about in the example previously did, you may choose to manually intervene in that case. So in that case, those applications were triaged off to a manual team who made their own assessments. All right. Just caveats apply here. As I say, I'm not recommending these tools. They're just a flavor you can take a look at if you think they might work. It's fair to say I think they're in the early stages. They are works in progress and continuing to evolve. Given the backing they've got, though, I expect that evolution will be quite rapid, particularly Microsoft. I'm not trying to favor them, but they do move quickly when they decide to. In this case, they have. Use with caution, check the details, and make sure you check and cross-check again. All right, so they're the tools. I think we've reached the end now. So that's a whistle-stop tour. It's a high-level review of the reason why I think you need to step into bias. Make sure you understand it. Make sure you've got a mitigation strategy in place. It can be distracting and misleading if you go down the wrong path. And I've tried to provide a few waypoints there to help you not do that. Testing, in my view, as I said, testing model output and testing against policy for AI is really the best approach to do it. It's not hard to do. You can get quite quick results quite rapidly. So, all right, if you need any more information, of course, feel free to reach out, make an appointment, book in a slot, and I'll try and get more detail to you as we can. All right, back to you, Gunnar.
Thank you. Thank you, Brian. I'll make sure I'll post the link to schedule a call with Brian in the comments. And now we have about 10-15 minutes to take a few questions from the audience. So guys, if you have any questions, please post it in the comments on LinkedIn or YouTube, wherever you're watching us today. Brian, there is a question here from James, just sort of like the overall about AI bias. Given that AI at this stage is essentially always learning data and source referencing tool, that is sourcing human input and created data, would it be possible that AI bias is nothing more than input bias?
Yeah, look, it's a really good point. As the data, I mean, we're using massive amounts of data now, particularly for LLMs. We're effectively scraping the entire web. But even in dedicated areas or focused areas, there's large amounts of data. Input, it may be input bias, but it doesn't really matter. It's bias. And I think one of the key aspects that I've attempted to address and mitigate by using the testing approach is the perception of bias. A lot of this is going to be driven by perception. Your executive will want to appear to be squeaky clean, and so what its source is, whether it's input bias or if it's intrinsic bias in the data, I don't think it's going to be too important to them. It's the outcome they'll really be interested in. Now, that said, my personal view is almost every corpus of data is biased, and not only that, that bias drifts over time as the corpus evolves, or as your analysis of that corpus evolves algorithmically. It's unavoidable. Bias is unavoidable. And I gave the example before of the discrimination against red-headed executives in Fortune 500 companies. That was always there. No one found it because nobody was particularly concerned by it. So there are a plethora of other kinds of measures that you would find bias along as well.
Perfect. David mentioning about the approaches that didn't work. Interesting. Good. Get a critical analysis of these techniques. I've been reading about it, and I think, Brian, we did run a little poll before asking people for their opinion, which approach is the most effective for mitigating bias. And quite a few people actually, I know it was a tiny poll, only 30 people, but it's interesting that people choose auditing training sets as the most effective approach. Just what do you think? What's what's the biggest misconception there, and what's the biggest mistakes? I guess most common mistakes people do then, like using different techniques, in your opinion?
Yeah. Look, I mean, these are techniques that are being explored by the community at the moment. Auditing training sets, that I think we've got half of the votes on that. That can yield some results. But again, I think you end up going down the garden path with that technique. There's no bottom to what you'll find if you audit the training sets. And the key question, of course, with any audit is audit against what? And that becomes, one of the key weaknesses, I think, of that approach. It is something that will get you some information. Some of the time, of course, it's difficult to get hold of the training sets. If you're using third-party models, they won't disclose those training sets in some cases, particularly when you're looking at things like credit models in the finance realm. So in that case, testing model outputs against the policy that you've got is really the only method.
Perfect. Thank you, Brian. And I guess just to summarize our today's webinar, if you want to give the 1 minute top tip for any CTO out there who starting deploying some AI deployment, if you summarize it in 1 minute, what would be your top tip to people out there?
Yeah, look, the main takeaways there, I think, bias in AI is something you have to consider. It is arguably a hygiene factor. However, it's something that you need to take seriously. It's something you need to have a position on, in my view, because you will be asked about it by your executive. They will want to know, they will want to have confidence that you've got an approach that is going to protect the organization. And then the third thing, I guess, is it's not, in my view, as complicated as it first seems. A simple approach driven by policy and then backed up by testing of model outputs is going to get you most of the way there.
Perfect. Thank you, Brian, and thank you for everyone to joining us today. This brief lunch session. If you're tackling a complex challenge within your organization, as our value webinar attendee, you have a special opportunity to book a call with Brian, as Brian mentioned. So I'll make sure to put the link in the comments. And additionally, if there is any specific AI topic you would like Brian to cover in a future session, please share it in the comments or message me directly. We aim to organize some follow-up webinars early next year, so would love to see what sort of topic you want us to cover. And to stay updated with our upcoming events and webinars, just as usual, follow us from here on LinkedIn, from here on page, and subscribe to our YouTube channel, depending on your preferred platform for consuming information. So thank you again, everyone. Thank you, Brian.
Thanks, Jana. Thank you, everyone. I hope that was useful.
Thank you, and I'll hope to see you next year. Thank you.